disadvantage of VPN servers deployed on your private network is that due to the need to accept incoming tunnel connections from clients on the internet, the IP address needs to be public and ports need to be open on firewalls. This can lead to the discovery of the VPN service and denial of service attacks. As OpenVPN Cloud is offered as a service, it is our servers on the internet in our different worldwide regions that need protection from denial of service attacks. Your private network is not at risk. Only an outbound tunnel is set up from the private network to OpenVPN Cloud Region. The firewall on the private network can be set to restrict all inbound connections, making your private network invisible to probing. OpenVPN tunneling protocol has a built-in safeguard to protect against denial of service attack by adding an additional hash-based message authentication code or HMAC signature to all SSL TLS handshake packets for integrity verification. The HMAC signature provides an additional level of security above and beyond that provided by SSL and TLS. It protects against denial of service attacks or port flooding on the OpenVPN UDP port. It protects against port scanning to determine which server UDP ports are in listening state. Protects against buffer overflow vulnerabilities in the SSL and TLS implementation. And it does protect against SSL TLS handshake initiation from unauthorized machines. A network cannot be attacked or targeted if it cannot be discovered. Now, some ZTNA solutions talk about their ability to cloak the application behind their solutions from being discovered via internet probing techniques by using single packet authorization or SPA. Even though OpenVPN Cloud doesn't use SPA, it has different levels of protection to cloak your private resources and provide only authorized access. Only packets with a valid cryptographic signature solicit a response from the service to start the process of establishing a tunnel. To establish a tunnel successfully, both the client and the server need to have the right certificates. The right tenant identity needs to be established and authenticated for access to a specific custom resource. Typically, a legacy VPN will push the entire route of the private network to every client. OpenVPN Cloud automatically microsegments the network based on the configured IP services and their authorized users. When user accounts connect, it then sends routes to just the authorized microsegments. As you can see in this slide, in our environment we have three configured IP services. One for the file server, one for the web server, and the last one for the database server. We also have three access groups set up in our network: for the DB team to access the database server, and the sales team to access web server, and marketing team to access file server. Make a note that automatic segmentation prevents lateral movement. If the sales team is compromised, the DB server route is not discovered and cannot be reached. Again, if the marketing team or a member of marketing team is compromised, the web server and database server are not going to be reached and they're not going to be discoverable. Now let's look at the micro-segmentation for the IP services. I'm logged into the administration portal, and if I go ahead and look at my WPC, you can see that my topology is set to full mesh. So if I log in with any of the users, the whole network or private network is going to be pushed to a client. So if I look at the logs, I will be able to see my whole network. Here we go. So you can see the two IP addresses for the WPC here, and then you can see my private network. So everything is pushed to the client and we can see it on the log. Now if I go ahead and disconnect from this user and change my topology to custom and let the access groups come into play. Let's look at the access groups here. I have multiple access groups set up. As we talked about in the previous slides, I got DB team, marketing access group, and sales access group. So any of the users from these access groups connect to the network or WPC, they're gonna see only their own segment. So you can see my groups. Let's look at the users, and you can see each user is assigned to a group. For example, here Jordan is assigned to the sales team. So let's go ahead and log in as Jordan and take a look at the logs. So it's connected. Let's look at the log, and here we go. Yeah, as you can see, he has only access to the server that is assigned to his access group, and we can see the two IP addresses for WPC. Now keep in mind that WPC IP addresses /11 is almost a little bit over 2 million IP addresses, and the /12 is a little bit over a million IP addresses. With this large range, makes it really hard to scan a WPC network. Now let's go ahead and disconnect from Jordan, and we're going to connect with another user. Kim is part of our marketing team, so let's go ahead and click on her profile and connect Kim. Let's look at the log. Here it is, the route. As you can see again, in her log we can only see the segment that she's connected, and then the two WPC IP addresses. So this is how microsegmentation for the IP service works on OpenVPN Cloud. Another and maybe the best way to cloak your private services is to assign them a domain name in either your private DNS servers or using OpenVPN Cloud DNS records. A connected user cannot discover your private network IP address range, and OpenVPN Cloud provide IP addresses from a different subnet to reach those private applications. So what cannot be discovered cannot be attacked. You can see in our environment we have a server, accounting server, with the domain name accounting.local already assigned and set up in our DNS records. We have an access group for accounting team to access the accounting server. Now we're going to look at how we can set up domain names for routing and completely cloaking the private network IP address routes. I'm logged into administration portal. The first thing we're going to look at is our DNS. So let's go to DNS and look at the DNS records. We already have accounting.local set up as in our records with the private IP address for that accounting server. Now if I look at my access groups, I already have an accounting access group set up for the accounting team, and they're going to use the accounting services, which is the accounting server with the accounting.local name. Let's look at the users. So you're going to see I have a couple of users that they belong to accounting department, like Bruce and here Karen. So if I connect with Bruce's or Karen's profile, we shouldn't see any of our private address range in our logs. It's not going to be pushed to the client. So let's go ahead and connect with Bruce's profile here. We are connected, and we're going to look at the logs. Scroll up to the routes. Here we go. As you can see, we only see the two IP addresses for the WPC. Nothing visible from our private range here. Now, if I go ahead and disconnect from Bruce and connect with Karen, another member of accounting team, I should see the same results. So again, go scroll up to the route, and here it is, the two IP addresses for the WPC, and nothing visible from private range. Again, remember these two IP addresses from WPC is /11 and /12. One has over 2 million IP addresses in its range, and the other one has over 1 million IP addresses in its range. So with this large range, it's really going to be hard to scan all the IP addresses for WPC. So this is how you can use domain name or for routing and completely cloaking and hiding your private network IP addresses routes.